welcome to Teaching Mathematics. Today we're joined by Tamlyn. Hello, Tamlyn.
Hi, Helen. How are you?
Good, thank you. And yourself?
Well, thanks.
That's good. And hello to Dylan behind the mic.
Hello.
Or behind the buttons, at least. Okay, now before we get started with all the content, as you know, you can talk to us during the show. You can talk to us using Twitter and the hashtag MEMaths, or using Facebook. Search for Digital Classroom South Africa, find the post with today's picture on it, and then comment below. Dylan will be watching both of those channels. There is another way to talk to us, a new and exciting, a new and improved way to talk to us. If you scroll down on the page, you'll see that there's a little chat box. You enter in a nickname, you press enter, and then you can start having a live chat with whoever else is there.
Okay.
You know what's nice about that, Tamlyn? Some of us don't like to have Twitter or Facebook because then our students find us.
Yeah, that is true.
Yeah, and they harass us. I remember getting a request on Saturday night at 11 o'clock. How do you do this question?
Oh, gosh, yeah, I know.
So teachers who aren't on Facebook or Twitter can now talk to us without logging into any of them.
Yes, secretly.
And you can win 110 rands airtime, Vodacom airtime, if you talk to us on any of those. Yes.
Super.
The one other thing you can do to win, and for this you win a phone or a tablet.
That's exciting.
Yeah,
wow.
it is. And if you don't want one, you can wrap it up and give it to someone you love for Christmas.
Yeah.
Or someone you want to love you.
As a new, how handy they are. So it's fantastic.
Yes. So if you want a tablet or a phone, you need to just send us a resource that you use with your teaching, and possibly linked to statistics, like we're discussing today.
Okay.
Or another section in mathematics. All you need to do is watch out for the secret code that will appear somewhere at the bottom of your screen at some point during today's chat.
Okay.
Write it down, send us an email at competitions@digitalclassroom.co.za, and then we'll make them public.
Oh, that's great.
And we'll choose some to win.
Do they need to include things like memos, the resources?
I would think so.
Okay.
Yes. But a resource can also be, because I really want to see videos of lessons.
Videos, okay.
It can be a video of you teaching a particular way.
Awesome.
That's exciting.
Yeah, absolutely.
Yes.
Yeah, because you don't always have to go to the test or the worksheet kind of resource.
Yeah.
Absolutely.
Or a website that you found and how have you used it?
Absolutely.
Just tell us what you've done in your classroom.
And there's just so much out there. So, yeah, for sure.
Yes. Okay, now, Tamlyn, tell us a little bit about yourself.
I currently teach maths at a private school here in Johannesburg. I've been teaching maths for a very long time, kind of spanning from having a private tutoring maths centre for many years, where we taught children from a variety of different schools in the area. And I then moved from there to a school, a much bigger school, and taught it as a government school. And I was there for 3 years. And then after that, I've now been at this current school. Much smaller environment, quite different to what I was experiencing at the government school. But I must say I was really glad that I had that opportunity, because it gave me a really good, rounded perspective on how to manage a class and how to teach different sizes of classes and different types of children. So it's I feel
of course, there are different difficulties with each one.
Oh, definitely. Absolutely. So
there is this misconception that smaller classes make for easier teaching. It's
a smaller class, you have to actually be a bit more on your top of your game, because they'll call you out much quicker if you are not, if you're not explaining something clearly enough. In a large class, you'll probably find they tend to sit back quietly and just kind of let you carry on, whereas in a class of only 15 children, someone will put up their hand and say, no, ma'am, please explain that again. I didn't quite understand that. So
you can't just read from the textbook and hope that they get it.
No, absolutely.
Okay, before we get on to the content, which is grade 10 statistics, let's look at this book I've been reading, Teach Like a Champion. And, of course, you've been here before, so you know that I've been reading one chapter a week.
Yes.
And, one technique a week.
Okay.
Yes, and this one is technique number 15, and it says circulate, and I like it. It says move strategically around your room during all parts of your lessons, and then it's got all of the pros and cons of doing this. One of the cons being that if you do it too strategically, you become predictable in your movements, and then weird things can happen in other places of your classroom while you have your back turned, things like that. But I think the pros far outweigh it.
Absolutely. No, I must be honest. I know in my experience, it keeps the children's attention. It makes sure that they don't drift off, that they don't think that they can get away with maybe doing something that they, maybe doing an English assignment while they're sitting in maths class. So I think it's an absolute must that just in every way to keep good control over your class.
Yeah, and Dylan and I have spoken about this kind of thing before, so I'm hoping he'll tell us a little bit more about his theory.
Well, I've got two theories. That moving around the class is one of those things that is really crucial to being able to assess constantly what's happening in your class. Is what you're teaching now and then, is it hitting the mark? Is it scratching the itch? And I think the best way to do that is to go and interact with the kids that you're teaching.
Yeah.
I think the other thing that moving around strategically does is it helps you, as you were saying, to keep control of the class. And the thing that I've mentioned to Helen before is this notion of there being three positions almost in the class, where the one position is up front, and that's where you deliver instruction, that's where you deliver discourse to the entire class. And then there's this mid-distance where you're not necessarily talking to the whole class, but you're engaging at a slightly more intimate or deeper level with a group of kids. And then there's the third distance, which is being really close to a particular learner. And I think sometimes we as teachers get confused about what each position is for. And so often we make the mistake, I think, of using the first position in front of the class as our position of discipline. And actually that's the worst, one of the worst things you can do, because it just makes the spectacle, the scene, Johnny, you're in the back, keep quiet. And everyone else in the class says, oh, well, that's interesting, let's keep making a noise, because this is, we're not going to have to learn
diverting
anything.
The attention,
Whereas if you go up quietly to Johnny and you just say, Johnny, if you do that again, we're going to have a real problem. Suddenly you make it not about the entire class, and you're addressing that one issue. So just my 2 cents worth.
I also think what I've also found is that moving around, sometimes you're more withdrawn child who would never put their hand up and ask a question when you're standing in front of their class. As you're moving around, as you kind of walk past them, they kind of grab the opportunity to say to you, hang on, ma'am, can you quickly just explain this to me, without making a big scene of it. So it also gives that learner a chance to ask a question.
The book actually talks about that quite a bit, saying that you've got to find people, you know who your problem cases are. From discipline, from maybe children who need extension, maybe children who need support. And you've got to plan to be at their desks at particular points.
Absolutely.
To support them.
Yeah, and I mean, obviously, the better you get to know your children, the more effectively you can do that. So.
And you can read body language as well.
Always,
Yes, you can get to know when little Johnny's about to act up. You can see it in his eyes already.
Yes.
All you have to do is go stand next to him, and I used to put my hand on the desk just so that he could see.
Just so they knew you were there.
Yes.
I think absolutely. I think it's an extremely good strategy to have in a classroom.
But Dylan also mentioned assessment. So often when people talk about assessment, they think of paper and paper and pen and marking, red pen. And it's not, is it?
No, I mean, when you talk about continuous assessment, I mean, that's one of your most continuous, is that you are, through body language, through just watching the way a child is. In fact, it's quite funny. I have a particular child who, he's always writing. You can see he's always writing. But when I go close to him, I can see he's not writing at all. He's trying to look like he's writing, to try and make me think that he's managing. Yeah. But as soon as I go to him, I can see that he's not managing at all. So, but if I didn't go close to him, I wouldn't have that opportunity, and he wouldn't have that opportunity to actually sort the problem out.
Yes.
So, you've got to, it's actually essential. Otherwise, you're really missing out on so much of your teaching.
Well, it's say you're multiplying negative by a negative, and you realize they're not getting it right. You can see it immediately. You can correct it before the lesson's finished and they've gone home and done homework badly.
Yeah. So, I mean, it's a case of teaching a section and then saying to the class, okay, right, for the next 5 examples, you guys are on your own, and while they're busy, so you go around and, give them that chance to ask if they need to.
Yeah. Okay, now we're here to talk about grade 10 statistics.
Yes.
And we've been speaking about this for the last hour before the show.
Yes.
And my question to you was, why do we even bother?
The problem I think with statistics and the way it's sort of presented is that it's quite repetitive through the years of grade 10, even grade 9 when we start introducing data handling. So I think possibly the children start questioning what's the point. But if you in any situation out in the world, data and the collection of data and the analysis of data is such a crucial element in so many different aspects of any sphere of work out there.
Yeah.
If I look at how I analyze the results and the marks that the children are getting in their tests, and I'm just a teacher, and then you look at someone in the corporate world and how they're analyzing sales and trends and all of those things. I mean, it's crucial that everybody have some basic knowledge. Obviously we've got our statisticians out there who are going to really delve deep into the world of stats and all the intricacies of that. And not all of us are necessarily going to go there. But having said that, if any of your corporate degrees and what have you are going to include an element of statistics in them, and I think everybody should have a good, solid, basic understanding of what it is out there, because the world is full of it.
But mean, median, and mode. Okay, yes, we do a few extra things in grade 11 and grade 12. Are we really doing it any justice?
We are limited in the classroom in terms of what we can do. For us to run out and go and do an actual sample, we're limited. So that's why we as teachers have to be a little bit creative with how we present the data, how we actually do it, because do they need to know about mean, median, and mode? Absolutely. It's important concepts that, again, those are things that are going to get applied out in the big wide world. So, yes, they definitely need to know that. In the classroom, we need to be able to do it in a way that's meaningful to the children. I sometimes find, these terrible little squashed blocks of data, and it looks, that's when I think the attitude towards statistics gets negatively skewed.
Nicely slipped in there, well done.
And the children just find it boring. So, I would say our challenge as teachers is that we need to be able to try and just, present it in as an exciting way as possible. It's
maybe
the section.
The key is in what you said about making it meaningful.
Yeah, absolutely. Use information, Facebook statistics, cell phone, data on cell phone usage. Those are things that I think children in schools today find it's valuable.
Can I tell you, when I was studying and we had to do a project on how to teach statistics, we chose to do one based on which bathroom stall was used most frequently.
Okay.
And that has always stuck with me.
Yes.
And I always choose bathroom stalls according to which one is used less frequently.
Yeah, well, absolutely.
But I think there's a lot of merit in finding meaningful things.
Yes. And it's a very visual section as well. So I think, it's an opportunity to allow the pupils to be creative within their own work. Let them use color. Let them make it interesting so that, there's also, graphs that are all one color and not drawn nicely. Those are awful. So, it's an opportunity for the children to sort of just enjoy presenting the work well as well.
I wonder if there's any room for infographics. Those things.
Yes.
It's like the posters with all of those information. If there's any room for that kind of teaching within, especially grade 10, when we are really repeating a lot of the stuff we've had before.
If you're in a privileged situation where you have multimedia in your classroom, if you have projectors and you have access to smartboard and things like that can really make your presentation to the class just that much more polished,
Yes.
to draw a bar graph where, the thing is, if you don't have a smartboard, it doesn't mean that you then have the excuse to just do a very scribbled, inaccurate diagram on the board. That's really important, is that the way we present the diagram is their first impression of it. And we've got to make sure that whatever means we have in order to do it, we've got to do it properly, because I think that's also of keeping their attention in the section or losing them.
Okay, so going back to the meaningful thing, if we are presenting a diagram, surely when we present it, we should also be discussing it and analyzing it the whole time.
Yeah. Well, if we go when we go through the sort of steps in terms of how we teach it,
Shall we start?
Yes, we can, and let's
Okay.
talk about that.
Can I just jump in here quickly?
Yes.
Because I'm not actually sure the answer to this, but how specific is the curriculum in terms of encouraging teachers to not just help learners understand the mechanics of statistics, but understand almost the emotional side behind how statistics or how this data can be presented to make a case for one side of an argument against another, and are we giving learners that ability to interpret and make sense for themselves the data that is being presented to them?
I think in one aspect, if I think about the syllabus, in one part of it, they talk about misleading statistics and how we teach the learners how you can present a graph in a way that can actually mislead the interpretation of it. So, we were saying if a child took their maths tests over a term and they got 40%, then they went up to 70%, then they went down to 20%, and they had this huge variation of marks. If they were to graph that, but they kept the increments on their graph quite wide, it could almost actually look like the bar. If they were to draw, say, a broken line graph of that, it could almost look quite consistent.
Yeah.
So if they went to their parents and said, "Look, Mom, look how consistently I've worked in maths this term," just by showing her the graph, that's an example of misleading the statistics. So in terms of what's included in the syllabus, that element of it is definitely there. In terms of just helping them understand that side of it.
There's a good book called Freakonomics, which I read ages ago, and it did change my view on statistics as well as teaching it, because it was interesting.
Heard of it. I haven't read it, but I have
You
heard
should.
of it.
It's not too intellectual, so I could cope with it.
Yeah, no, that's fantastic. I have heard of it.
But I'm sure there's a website that summarizes all of their findings as well.
Absolutely, yeah.
Okay, now let's take a look at the 5-point teaching strategy. The first one says, teach the statistical process of collection, representation, and interpretation of numerical data.
So what I sort of coming from there is that teaching this section could be a little bit vague in terms of where do we start? How do we go about teaching this? So I think to approach it from sort of a step-by-step process, I think is good for the children just to understand where the process starts and where, that you would need a graph and you would need to order the data before you can start interpreting the data and so on. So the collection element of it, again, in terms of what we can do, normally that obviously is given to us. We don't go out there and collect the data as such unless it's a project or something.
Yeah.
So that element of it is, it's important for them to understand how we collect data with questionnaires and all these different means of going about and actually gathering that data. But then once they understand that that's the first piece of the puzzle, then the representation. So they need to understand that once you've gathered this whole pile of questionnaires, you now need to make some kind of order of that. Okay, it's not going to mean anything to anybody if it's not put into some kind of order. So organizing it, putting it into groups, setting it out, and then from there representing it. So putting it into graphs, whether it be a pie chart or a bar graph, or how do we want to actually represent this pile to make it meaningful? Again, the meaningful part of it. And then once obviously you've made this picture, this graph of what you've now collected in terms of data, to then say, okay, now that we've got this all neat and tidy, let's work out things like your mean, your median, and obviously.
Okay, so as you know, I've done quite a bit of work with maths literacy as well, and all of those are covered in grade 10, 11, and 12 maths literacy as well. Maybe it would be worthwhile doing a project with the maths lit children where they could focus on the data collection process, and then you could group the data together and then both groups then represent it separately and do their calculations and then compare at the end.
Absolutely. Yeah, absolutely. I think again, it gives it that meaningful element to the section and not just being lumped with a pile of different sets of data and they have to analyze it. So I think it's a really good opportunity. It's a good section for a teacher to introduce a project and to let them go out there and do a study of some sort.
Yeah.
And actually put it into practice.
It could turn into something really exciting.
Absolutely. And you've got to have, just having done these projects with the kids in class, they've got to buy in. They've got to, and again, I suppose that comes down to us choosing a good topic, something that they can invest in. And yeah, so with one thing I have found with statistics in class is that you can either keep the children or it's one section that they tend to lose focus on. So
yes.
So it's definitely something that, to choose a project that can be well studied, something that they can really get their teeth into, that they can actually get some meaningful information out of. And then, yeah, it's a great section to make practical.
Yes, I think so. I want to come back to that thought and let it develop a little bit more. And then, of course, you interpret the data using measures of central tendency and measures of dispersion.
Okay, so in grade 10, you've obviously got your basic measures of central tendency, so your mean, which is just your average, the median, which is obviously your middle value with your ordered set of data, and your mode, your most often occurring value. And then your measures of dispersion, so how is the data spread? Okay, because that's obviously interesting. The mean sometimes is very much affected by, and that's often the case with box and whisker diagrams, the mean is often very much affected by the spread of the data.
Yes.
So your quartiles, your range, your interquartile range, and so on. And then your 5-number summary. Okay, so your box and whisker diagram, which is now sort of a new introduction to the grade 10 syllabus with this. And it's actually a very nice representation of the spread of data. And a really big, a really important skill that the learners need to develop, especially in grade 10, because it will follow through in grade 11 and 12, is how to actually interpret these box and whisker diagrams, because there's definitely a challenge in them.
You see, I was just about to say that the 5-number summary is... Summary? Yes. Is one of the easiest things I've ever had to teach. It takes 5 minutes and you've got it taught and then you show them how to draw it and then it's done. But actually interpreting it.
Yeah, absolutely. It's very easy to just draw it. But definitely what I'm finding in sort of papers and exemplar papers is that, the expectation is that they actually have to make some kind of comment on the diagram itself and what it's actually saying. And also comparing two different diagrams, and actually having the opportunity to say what's the, not just stating the obvious, but actually comparing them.
Okay, so I'm going to make a guilty confession over here. If I were teaching this, I would probably say, okay, this is how you do it, this is how you draw it, and if it's this way, then it's negatively skewed, and that way it's positively skewed, and then they'll ask you to interpret it, give it your best go, but don't worry, you've got most of your marks already, so it's... If you want 90%, then you answer that question. If you don't, carry on and do trig or whatever else is in that paper.
And probably you'd find you're not the only one who does that. But I think if you... Shocked.
Whoopsie.
But I think if you just take a moment to, study it, think about it, it actually does things start jumping out at you. And the more you actually,
well, let's take a look at this one that's down here.
Yes.
Okay, I recognize South Africa, New Zealand, and Australia.
Okay, so these were this was data that I pulled off the internet, and it was with the Super Rugby League, and I had a look at all the different.
Do you watch
scores.
Rugby?
Yes.
Okay, so you can talk about it with some understanding. So it's meaningful to you.
I'm not going to claim much authority on it, but I can say I know that those are the 3 countries that play. Okay, so obviously each country has its individual teams, and basically what I did was put together a study on how they each performed in the logs, okay? And so it was quite interesting because if we look at the data, it's actually quite similar. Each one of them, it's not very varied in terms of the data. South Africa's average in terms of the different teams that played worked out an average of 47.8 average scores. New Zealand 48 and Australia 46.2. Okay, so the averages are very, very similar. So in amongst, yes.
An average of what? Is that points scored
There
during a game?
Yeah, so we just took all the different points of, so for example, if I take South Africa and the different teams that South Africa had was Bulls, Cheetahs, Stormers, Sharks and Kings. Over the season, the Bulls scored 63 points, the Cheetahs scored 54 and so on.
Total.
So what we did is we added an average overall score of the teams. Okay, so that's that. And yeah, as I say, the teams, the various countries, their teams were fairly similar in terms of average. Okay?
Yeah.
But then we did our box and whisker diagram, which obviously it was your lowest point, your highest point, and then your box representing your interquartile range, which was your Q3 minus your Q1, and the line in the middle representing your median. So what can we interpret off of this? So I'd probably say the first thing to mention if you're making some kind of comparison is look to see where is the skew? Are there any skews, or is there any symmetrical data over here? So the first thing that I would state here is that although Australia, if we look at the average, we've got a 46.2%, not percent, 46.2 average in terms of score, which is the lowest amongst the three teams. If we look at its spread of data, we could actually make a comment that Australia is actually the most consistent scoring team in the competition.
Yes.
So although they didn't necessarily have one team that went way out and did particularly well or particularly badly, if you were possibly putting a few cents on betting on a team to win or lose, whatever, Australia would probably be your most reliable team.
And we say that because the box
spread,
and whisker.
So you've got a very symmetrical spread of data over there. There's no one side that represents that's longer than the other, which represents a greater spread. Okay.
And like South Africa, where you've got that long arm.
Yeah. So South Africa, if we look at here, we've got a 48 point average for New Zealand and 47.8 for South Africa. So those two were actually quite close. They were neck on neck. But because of this over here has got so much of a longer spread than so this 25% of the data is so much wider than that 25%, it's probably pulling that average up a little bit higher. That's the reason, as well as obviously what's happening is our longer spread on the lower quartile side there. So in fact, it's actually another interesting point to mention if you were stating things about this. South Africa's median is actually higher than Australia's. New Zealand. So we've got a higher median. However, because of the greater spread of points on your upper quartile as opposed to South Africa, so the average for New Zealand is higher than what it is for South Africa. Okay. Also, stating things such as, you've got a positively skewed set of data. This is not very negatively skewed, but we could state that it's slightly negatively skewed for South Africa's data. And then, the sort of your consistent data is definitely your Australia's points.
Okay, so this may come as a surprise, but I'm a girl, and this doesn't really mean much to me.
Okay.
And I know that's a terrible stereotype, what kind of activities could you do for a girls' school?
What I would maybe say is, you could actually take the averages out completely, because sometimes the averages actually give you too much. So if the averages weren't there, if I actually erased those and nobody had those over there, then by means of just the box and whisker diagram, we could comment on who is the best scoring team, who's the one who actually does the best.
Lot, yeah.
Okay, so we could look at this and say, okay, well, who's done the best here? We've got the highest median in terms of points with South Africa, all right? Mm-hmm. However, there's a greater spread on the lower on the bottom half of the data.
Yes.
So although its median is much higher than both New Zealand and Australia, because of the greater spread of data, the average is definitely going to be lower than that of New Zealand. Possibly, it's a tough call. We don't have exact numbers here, so we could comment that it's probably, the difference between that higher median as opposed to that median and the spread. Is that spread enough to cause the mean to be lower with Australia than South Africa? Possibly not.
So by taking away those numbers, you can do a comparison.
You can do a comparison. It's, you've got to, we don't have numbers, so you would have to just state what you think and back it up with a good enough reason. So I could say that I believe that Australia would be the best performing team, even though their median is lower than it is for South Africa,
Yeah.
because they have a much greater 50% of their teams.
Do you mean New Zealand then that you're talking about?
Yes, sorry.
Okay.
Sorry, I'm mixing up my countries.
We
So New
won't tell them.
Zealand's got a very wide spread of data,
Yes.
as opposed to South Africa, which has got a much greater spread of data on the bottom 50%. So the average is going to be influenced by that.
Okay.
Can I just jump in here?
Yes.
The fact that there are no definites here,
Yes.
is that not part of the point of this thing?
Yeah, so
That statistics will paint some of the picture, but there's quite a bit that you need to fill in for yourself, and perhaps how you fill the data in shows some of your biases.
absolutely. Especially with data that's probably a little bit close as it is over here. You know, there's not much in it between the three. So whatever comments, and in fact when I was marking this, I had to really consider what the children said when they made a particular point, you know, as to if they decided that Australia was the best performing team. You know, okay, so why did they say that to me? Because, you know, it's the most consistent performing team was definitely the word I was looking for there in terms of marking them correct. I definitely wanted them to point out to me that South Africa's median is much higher than that of New Zealand and Australia. But because New Zealand had a much greater spread of data in the upper quartile and the upper 50% of the data, it would have caused the average to be higher than that of South Africa. So those are the sort of comments that I wanted them to make in interpreting this data.
Okay. Yes, Stella?
One more quick question, if I may.
Yes.
Of course.
Thank you. Would you go as far as okay? So say you collect similar data for, I don't know, for South African soccer teams,
Yes.
Lander Pirates, Kaizer Chiefs, you know, Wits. Would you put the data into your class and just, in a sense, let all hell break loose, and allow and allow kids to argue their point based on the data that is being represented as to which they think is the best team?
Well, I think it's a great way to do it, because if you're having to justify your answer, you're really having to think about it. You know, if you've had a chance, if you're having to really prove your point, that's when you're thinking about it. So definitely, I would say it's a great way to do it.
Or spin on that idea. You collect the data from the soccer teams at school.
Yes.
Under 14s, under 15s, under 16s, under 17s, on the goals scored per match, and then draw a box and whisker plot for each one,
Yes.
and then argue which team is the most promising
Yes.
based on that.
Yeah. I mean, again, you've got to look at what are you looking at? Are you looking for a team that's going to score no goals for 3 matches and then score 7 goals in 1 match, as opposed to one team that scores consistently 2 goals every single match? Because they're probably going to land up with the same average.
Yeah.
So they're sitting with the same average. But then you've got to decide, okay, well, hang on a second. If you just based your decision on average, it's not the most accurate of decisions. That's where you now need to look at that spread and say, well, in fact, the median of the team that scored 0, 0, 0, and then 7 is actually going to be 0, whereas the one that scored 2, 2, 2, 2. So then you're suddenly looking at your median, which is going to skew the data, and you're going to get that more accurate representation of it.
And the fact that the team with the higher median is probably going to be the more successful team.
Yeah.
Because they would have a greater chance of winning more matches than the team that has this one game with lots of goals in it.
Yeah. So definitely. So I mean, it's just, it just really depends on the data. But that's, I think, why, you've got these, you've got this kind of representation that you have a chance to actually not just look at the median on its own and the mean on its own, but what actually happens when the mean is greater than the median, or vice versa, because that's when the influence happens.
I wanted to have this conversation because I think it's really important that we recognize that there are people in our class that are going to go on to become statisticians,
Yes.
and they are going to earn a lot more money than the majority of the other people in our class. And so we've got to nurture the love for statistics within those people.
Of course.
at this stage already.
Yeah, of course. And, I think something like, as a teacher, a box and whisker diagram is not the easiest thing to teach. And we might be a little bit guilty of shying away from it and kind of saying to them, okay, well, this is how you do it and that's that. But maybe a good idea in terms of teaching it is have a bit of a sort of an action plan in terms of what you expect them to answer. So as I was saying, if a question like this, I want them to mention the medians and the comparison of the median in terms of all three and then the spread of. So, when you're teaching it, to really emphasize those kinds of things so that, for those children who are getting it, that they actually really do develop an understanding and a sense of what a diagram like that really does entail.
Yeah. Okay, 3 pressure points.
Yes.
First one says, understanding which form of representation is most suitable for data types. Okay.
Yeah, so where I really found this came up was when we did a project at school where the children had to go off and do they actually had to do a questionnaire, and then from there they had to take only 3 of the questions and represent them in graphs. And certain graphs, such as you've got your discrete data and you've got your continuous data. So the study was to go and do a thing on the tuck shop, and they had to how much money each child spent at the tuck shop and what was their favorite cold drink and what have you. Now, data like what's your favorite cold drink? You had options of Coke, Fanta, Sprite.
Yeah, so it's discrete.
Juice. It's discrete. That would be a good example of using something like a bar graph where you've got your separate individual bars. They're not moving from one is not moving on directly from the next. And that, is individually representing each category. A pie chart would also be individually representing each of those categories. Whereas, how much money do you spend? And now you've given them categories. So I spend 0 to 10 Rand. Then the next category was 11 to 20 Rand. And then the next was from 21 to 30 Rand and so on. Well, each of those is going to continue from one to the next. It's a continuous range of data. So there, using a histogram, where now all your bars have been pushed together and the one flows from one to the next, a broken line graph. Those you've just got to make sure the children understand that certain graphs will represent certain types of data.
Yeah. Frequency polygons, they're in grade 10, aren't they?
Yes.
Okay. And that's when you join the midpoint of the histogram.
So we've got your histogram, and then at a glance you can see the spread of the data.
It's quite a mind shift to do that, because they've done histograms and they've done bar charts. They've done them since grade 1, these bar charts and then histograms. So, but to actually have that line, it's almost a connection to a broken line graph.
It is, yeah. And I guess it's just... so it's sort of an overview of the whole histogram and looking at it as a sort of a picture.
I like teaching that. I thought it was interesting, different. The next one says, understanding what each of the methods of interpretation involve and how to calculate them.
So I brought this in because I thought, obviously we all know what a mean is and what a median is, and obviously we teach that as a definition. The calculators that we have available to us today are always they're becoming more and more advanced. And a calculator, they have these functions that are available to us. And it's acceptable to use. Okay, so we've got an example here of the Casio, which I think we all agree is probably one of our most common calculators in the classroom. So, knowing that, if you're sitting with a data set of 30 numbers, for the children to sit and try and add up all those 30 numbers and they make a mistake halfway through, this is a very handy tool to have in terms of just making it that much more accurate. So if I can point out.
So I haven't actually worked with this in terms of statistics.
How to actually use it, it's wonderful. So basically to get to your statistics mode is you'd have to start at your shift button over there. So once you've pressed shift, you need to go off to mode and press your mode over there. Okay.
Okay.
Sorry, I've just made it smaller. And basically that brings up one of the options being stats. It says stats. It's your number 3 button on your calculator. And when we click on that, that brings up all our statistics functions on the calculator.
Okay.
Obviously from there, we don't have it on it live, so it's a bit difficult to show. But, you need to spend time becoming familiar with that, because not only is it helpful, but we're dealing with children nowadays that are so familiar with technology and they like to use it. So it's just it's a little tool, it's a little thing that they have in class that they really love using. And as I say, they're allowed to. That as we go into grade 11 and grade 12, we do standard deviation and we do the regression, the line of analysis. All of that gets done on this calculator. So learning that as a teacher is very important.
Now, I know that there are many reps out there who, if you phone them, will come to your school and do a workshop with you free of charge.
I think, if it's for free of charge, there's really no reason not to take them up on it, because there's so much there that can really, really be of enormous help. So definitely. Yeah. And quite hidden, unfortunately. It's not always obvious as to how to get to these things. So,
and then when you do get to the stats page, it's all written in Greek.
No, I know. To try and open the little piece of paper that gets included in the calculator and to try and figure it out there, it's almost impossible. So, I'd say you don't need to learn every little intricate detail of how to do it, but I would say just starting to know the basics. Yeah, absolutely. It's key to really teaching it. Using the tools that we have. That's the whole point.
Yes.
Yeah.
Yes, Dylan.
How important is it to the section to have one of those calculators, or can you still teach the section without access to that or similar tools?
It can be done, but I'll be honest with you, as we go through sort of grade 11, grade 12, they've introduced correlation coefficients and they've introduced your line of regression. Now, to calculate the correlation coefficient using your formula is a difficult, long-winded process. And one that the textbooks, if you actually look in the textbook teaches the calculator sequence of buttons, and it doesn't actually focus on the formula as such. So can it be done? Yes, it can. But I think it's putting you at the learner at a disadvantage, in that you could make a very silly error just with the amount of calculation that needs to be done. And there's also a time disadvantage, because the child who's got the calculator will work out that correlation coefficient quick.
Yeah.
Whereas someone who's desperately trying to work it out is going to take that much longer. So I would most certainly say, it's becoming almost compulsory to have that kind of tool.
Okay.
To be able to work this out,
I do wonder what's the point in assessing something that a tool can do for you.
I went to a lecture at Wits a couple of years ago, where there was a lecturer, and basically his argument was, why do we bother teaching certain mechanical things in maths when we have these tools that will do it for us? And he was actually using calculus as an example. He had a picture of a box, a 3-dimensional box, and it was wonderful. He had the little corner, the mouse was in the corner, and he was dragging it bigger and smaller, and as he was doing it, the calculation was being done as to what the dimensions of the box would be to maximize the volume of the box, which is what we do in calculus.
Yeah, it's a standard example,
well,
isn't it?
Absolutely. So I remember sitting there thinking, I don't agree with you, because I think it's so important to understand where that comes from, and I do still agree, I do still feel like that.
Yeah.
So, something like correlation coefficient. I remember learning the formula. When we were at varsity, we didn't have these calculators, so we had to do it the long way. Do I remember? Does the formula stand out to me? No. Does the actual meaning of what the correlation coefficient actually is, does that stand out? Yeah. So, to actually get to the correlation, if you're getting a 0.75 as an R, this is obviously not going into grade 12, but just as an example, what the meaning of the what that 0.75 is to me is more important than necessarily how we got there. So for something like stats, I just think it's a very handy. I think it's something that is a very good help.
So maybe teach them how to do it without a calculator. Let them do it for 24 hours without a calculator, and then show them. And then show them the magic.
Absolutely. No, having an understanding of where it comes from, I can't imagine can ever hurt. Maybe for that child that's struggling, certain of the formulas are difficult and they're quite complicated. So, you don't want to count them out as somebody who can't analyze statistics just because they're battling to understand this very complicated formula. when once they've actually got the answer, once they've actually worked out that standard deviation, they actually understand what that's about. So what's the more important thing?
Well, standard deviation is another topic which we'll be talking about when we talk about grade 11.
Absolutely.
Yeah, I look forward to that discussion. Yes. Okay, the third pressure point says understand how to interpret a box and whisker diagram.
Okay, so I think, as we've obviously spoken about this already, but I think it's a new element in the grade 10 syllabus, and it's definitely something that gets asked in grade 10, grade 11, and grade 12. So I just think as teachers it's so important that we have a way of just understanding it ourselves, and then from there being able to just impart that understanding to your learners on just how to go about interpreting it. There's no one way to do it. It's just an understanding of what the diagram is about. So,
and demonstrating an understanding.
Yeah, absolutely. So I think us as teachers have to really spend time on that and actually work on that, because I know that it's something that I think we all have a little bit of difficulty with. Just actually, in a nice answer, putting together what it is that we actually want.
Okay, so this is where I want to come back to that idea that I've been stewing over. What I would suggest, and I was fortunate enough back in the day to teach both maths and maths lit, so I could do this kind of thing. But what I would have done is have them do data collection. They work with the same set of data. Both groups work separately, and then they argue separate points of view. So the one is for something and the other is against something, and they use their data representation and interpretation to justify these examples.
I think it's a very good exercise, and something I wouldn't just do with maths literacy pupils, not at all. I mean, I do it with both.
Well, that's what I mean.
Yeah,
gives the maths lit kids some dignity and get them to fight against the maths lit maths
well,
kids.
In fact, and you know what, you probably might find that the maths lit pupils have a better understanding of it. Sometimes the core maths pupils have a little bit too much of an analytical approach to things, and they depend on the numbers a little bit too much. So, yeah, I think it's actually an excellent idea is to give them a chance to do that.
There is an argument that we have trained them to be more analytical and not think about what they're doing, just think on how to do it.
Yes.
Whereas maths lit, there is meant to be this focus on whole view approach.
Yeah. No, and I mean, I suppose, again, you can go back to using the calculator to work out the mean. We're focusing on just getting to the answer as opposed to the process of getting there. So, and I mean, I suppose we've got to be careful to not shortchange them on having a full understanding of where, and almost an appreciation of where this number comes from. It's not just a number that got spat out. There's a process, and sometimes quite a complicated process to get there. So, yeah.
And the conclusions you can draw from statistics are very interesting.
Always. I mean, so practical.
Now, this Freakonomics book, the one thing that really stood out for me was that they did a comparison of families that had books in the house versus the children's intellectual ability. And, well, this was one study that was done, and they found that there was a direct correlation, if I've used that correctly. The more books you had, the better your child performed.
Okay.
Now, this book went back and said, no, actually, the reason the family had more books was because the parents were better educated.
Okay.
And the reason the children were performing better was because the parents were doing homework with the children. Yeah. So the number of books versus the child's ability in school actually weren't worthy of comparison at all.
Yeah, and I suppose that's where, I mean, again, that's sample size and representative samples. All of that can skew a set of data so much. So the misleading elements of statistics is most certainly a very real problem with it. And, often I think,
it's fascinating, though.
I'm going to use an example of at the end of the year when the matrix marks come out. What have you? I mean, sometimes those statistics, are they fully representative? Are we looking at them correctly? When an increase in the overall marks, is that, as I say, you've got to looking at a representative sample, making sure that you are
That's actually a really meaningful exercise, going through this the matric marks in your lesson.
Yes. Because there's room for misinterpretation or misrepresentation there, and it's just an example. But I mean, in any situation, you certainly could absolutely misrepresent it completely. You can twist and change it really to actually do exactly what you want it to do. So your most accurate representation is obviously the
raw set of data
from the population, and then from the population you're drawing that representative sample from the population, and from there, then you stand your best chance of an accurate representation. So,
okay, we only have 12 minutes left. Okay, and you have brought a statistics project that you did with your class.
Yes.
Grade 10 statistics. Why don't you quickly run us through it?
Okay, so it was basically one of the practical examples that we wanted them to go out and do. So they needed to get into pairs, and they needed to go and develop a questionnaire. This is one of the few times that they actually get a chance to actually do the data collection. Otherwise, they just get given it. So they had to
I think in grade 10 you have the time. Grade 11 you don't.
Yeah, so it's a good exercise, because when you're developing a questionnaire, you get the chance to actually think about the relevance of a question. Are you asking it just for the sake of an answer, or are you actually looking for, what's the relevance of it? Understanding sort of, demographic questions, male, female, boy, girl, that's the same thing.
Yes, it is.
How many, just to balance it, make sure you're not having too many of those, because I think those types of questions are important. But so we gave them a couple of suggestions in terms of the types of questions that we wanted them to ask. Their study was on cell phone usage at their school.
Okay.
So what type of, apart from the demographic questions, their age, their gender, which grade they're in, all of that. Then looking at things such as, it depended on what they wanted to study, but did the person have a cell phone or not, as a starting question? Is their cell phone a smartphone? Do they use it for internet browsing? Then they could have done something like, how much data do they use in a month? And with that, obviously, give them intervals. So how much data do you use? 0 to 100 megs, 100 megs to 500, and give them an interval, because that would, when we represent it in a graph, be a nice example of continuous data.
Yes.
Okay. Whereas, which is your service provider? Well, you've got your MTN, Vodacom, Cell C. So they could have done a study as to how many were each one had, and then represented it in a pie chart, for example.
Yeah.
So they needed to go out and do all of that. And once they had put together their sample, we wanted them to collect it, sort of hand it out to about 30 people to get sort of, again, trying to get a good representative sample. Only asking 3 of your friends who are only in grade 10 and are only girls, you're not going to get an accurate representation of your data. So to teach them that by really going out there and collecting.
So you're teaching about question types as well as sample size
So they understand that sort of devising a questionnaire is not about just chucking a few questions together and that's it. It's thinking about what the final goal is, and that they had to have a goal in terms of what they wanted their project to be about. So, and then once they had...
Dylan has a question.
Yes.
Just on that point, have you found that this discussion about designing the questionnaire ever gets to the point of you have a goal in mind and you have a message that you want to communicate, and so therefore you construct the questions to reinforce the message that you particularly want to communicate?
Well, absolutely. And again, that's where you've got to, as a collector of data, as the one doing the study, to be very careful that you're not skewing the data just by the means of your question. Maybe even the fact of asking, do you have a smartphone? I mean, that might already be leading, as opposed to, or data usage or something. If I just wanted to know the type of usage that somebody gets out of their phone, by asking them how much data they're using, I'm already suggesting that they use data. So, yeah, absolutely. I suppose you've just got to be aware of it. There's so many things to just be aware of when you're setting those questions, because you can really go off path. Yeah.
Okay, section B.
Okay, so section B, then I wanted them to take just 3 of the questions that they had collected data on, as I've sort of just mentioned, and to represent, I just wanted them on one A4, so basically 3 separate A4 pieces of paper or cardboard to represent each of those findings. And to really make sure that they took care in terms of their presentation, that they made it clear. I actually specifically said that I didn't want it to be computer generated because that's too easy.
Yeah.
So I actually wanted it to be hand drawn, that they set up their axes and things like labeling. You know, that is something that so many of the pupils lose marks on because they've got to understand that if you're setting up axes, a vertical and a horizontal axis, it's got to have a label on each one.
Yes.
A pie chart has got to have a key.
It's got to
absolutely. So those were obviously things that we made sure we had to have on them.
Okay, and section C?
And then section C was then I wanted them to do an analysis of finding the mean, finding the mode. So all nothing particularly difficult, but I wanted them to use data from a different question for each one of them and to just state the mean, the median, the mode of their findings. Interesting to see something like if they'd worked out the mean of grouped data. So, for instance, if there was a question on data usage and it was from 0 to 100, 100 to 500, and so on, to do the mean of that, obviously, is then more, you have to take the average, or the midpoint and what have you. So, just, that they had to then choose what they wanted to, which question they were able to do the mean, median, and mode of, and so on. So... so that was, but I think the true value in this study was the collection and understanding how to put together a questionnaire, and also not just to have yes/no questions, or not just to have, I know they're called Likert scale, the spread of from if you rate something from 0 to 10 or something, so, to have a variation of questions like that is important. To make it clear, when someone's answering a questionnaire, they actually understand what it is that you're asking and so on. And then to also represent, I think I definitely found in this project that pupils didn't understand that certain graphs are applicable to certain types of data, as we've spoken about. And in terms of skills, I think that was an important one to develop.
Did they have an opportunity to compare their findings?
Not amongst. I didn't actually do that. So just among. So each one of them had their data, and in fact, it would have been interesting to do that as a follow-on from the project. Yeah.
Yes, Dylan.
Sorry again, it's me. Just a quick question: did you try and teach some of the, did you try and point out to the learners some of the pitholes that they might fall into before they embarked on this project, or did you actually allow them to find all the mistakes by actually making them during the course of this project?
We had taught the section, so we had sort of obviously made sure they understood all the graphs, and hopefully they had understood which graphs were applicable to which data and what have you. Probably their most uncharted territory was the setting of the questionnaire. We hadn't actually taught them, hadn't gone in much detail. So the expectation there was that they would have gone and done a bit of research on how to set up an effective questionnaire and how to just make sure that the questions they were asking were actually going to land up resulting in the answers they were looking for. So
I don't think that's the end of the world. I think they should be going out and researching that.
Yeah, absolutely.
We provide them with all the other knowledge in maths. Yet other subjects they have to go out and research.
And we just have such an immense amount of information available to us on the internet and what have you that the children have and honestly I think that they enjoy it. I mean, to be able to go off and actually really use the internet to learn. Yeah.
Okay, now we've got 4 minutes left, so we're going to go through your good ideas quickly because they were really good ideas, and I'll post all of this up on the blog, so please watch it.
Okay. Will the project be there?
Will the project be there? Can I post your project?
Yes, for pleasure.
Oh, no pressure, yes. So the project will also be there, and it's printable, so different way.
Super.
Okay, it's the first good idea says get learners to write their own statistics dictionary page at the start of the section in their books for them to refer back to. I thought this was an excellent tip.
Oh, good. Because, this is just one of my little things that I do. But at the beginning of the section, I literally introduce it by making them have a blank page and to head it statistics dictionary. And then leave it blank. And then as we go through the section, as we teach, we keep going. As we kind of come across a new word or any new concept that they just need, we go back to that page, rewrite it, and we write a little definition of what it is.
Yes.
Because there is quite a lot in the section of new words, new concepts that I think it's worthwhile.
And they can also add to it the next year.
Absolutely.
Yeah, so to have it there, and we keep coming back to this in other sections of work as well. Have somewhere that you can write notes that you can carry through these 3 years.
Yes.
It just makes sense.
It's not individual, isolated. It just carries on so much through 11 and 12. So, absolutely.
The next one says, have a large number of examples at hand and make sure that each learner has their own copy of the data. It is much easier for them to work with than to try copy it off a board or transparency. Okay. I know what that's like. It's like you're pointing there so you don't forget to write 45 and then 46.
Yeah. Let's be realistic. We can't let them gather their own data. So, fact of the matter is we do have to sit in class and we do have to work through examples that we have. So, first of all, have enough of them because you can actually get through it quite quickly. So, it's not a section that you want the learners to drift and lose attention because, you want to come back to controlling your classroom. You've got to keep them engaged in this section. So having a lot of examples is important. Making sure that they're clear. I go back and I have this image in my head of one terrible photostated piece of paper where we had reduced all these little things into time. We tried to squash 10 examples onto one page and honestly, it was terrible.
Yes.
So personally, I would say, it's one section. I would say take the time to make it look good. Set it out nicely. Yeah, especially in grade 10 where this is all introductory and they're all learning. You don't want them to get a bad impression of the section at this point because it is important and it's just, it's an important section. So, have it and giving them their own data. Trying to get them to copy it off the board is a disaster.
It just doesn't work.
It just doesn't work. So, honestly, save yourself the stress and just give them a copy of their data. Definitely.
Okay, the next tip says keep doing examples of both ungrouped and grouped data so the learners understand the difference and know how to work, particularly with group data.
I just found this something, it's very easy for them to work out the mean and the median and what have you of individual numbers.
Yes.
But as soon as you start working within intervals, working out the median and working out the median would be more in grade 11, but working out your mean, you've got to know how to do it, and and I just think it's a good idea to alternate, kind of have a couple of groups, and then just throw in a little ungrouped and mix them up a bit, so that they just learn to pick it up and to recognize. Because I often find if you do 20 of ungrouped, suddenly you get to the grouped, and you have to reteach how to do it. So just continuously mixing them, I think, is a good, just keeps them on their toes.
That is a strategy for teachers who aren't really coping with what they're teaching, to teach the easy stuff for 70% of the time, and then for the last 20%, throw in the hard stuff, and then a test for the last 10%. Yeah, and obviously, that's not going to benefit anybody. So no, it isn't.
Mixing it up with the groups and ungroups, I feel is a good idea.
Yeah. Okay, and on that note, there is no shame with not coping with the content. There is shame in not brushing up on your knowledge when you know you're not coping.
Absolutely. I think we all know where we have shortfalls. And I suppose statistics probably is one of the ones where most people do have a bit of uncertainty.
Well, you don't do it the whole year and then you do it for 2 weeks.
And sometimes it almost seems a little bit wishy-washy. Sometimes you're not exactly sure. There's the other sections, there's a plan and that's it, and you go through it. So preparing yourself with enough examples, preparing yourself with enough of your own practice that you've gone through it, it will make the section so much more enjoyable for you to teach.
Yes.
And the children will feed off that. If you're enjoying teaching it and you can throw in little bits of interesting stuff that you might have picked up along the way, the kids will draw from that, and you'll have a completely different story with them as well.
Okay, the last point on the slide says learn how to use the statistics calculator functions to cut down on silly errors and working out time.
Okay, so we've obviously chatted about that. It is available to us. We are allowed to use those calculator functions. So I just, going forward, as the children go to grade 11 and grade 12, where the calculations become difficult, it's worthwhile as the teacher also just being empowered and knowing how to do it. Because invariably there will be children in the class who will probably know a little bit more than you do.
And that's okay.
And that's okay, absolutely. Let them teach you. But know enough. Just know that you can use the calculator.
Your last good idea talks about getting them to conduct their own research project. And I think that's very valuable.
Definitely. Again, in grade 10, I think, look, with CAPS, we pushed for the syllabus. There's a lot of time pressure. But I think it's one section where it's worth just taking the time to do it. Again, I think you're going to get much better buy-in from the kids. They'll enjoy it. And it just emphasizes the practical element of it.
Yeah.
So I would certainly say so.
And if it is a meaningful project, they will remember it, like the bathroom stalls.
Of course. I actually quite like that.
On that note, it's the second and third bathroom stall that's used the most often.
I believe the first one is not.
Not at all. So always go for the first one. It's the cleanest. Tamlyn, it's been good having you. Thank you for
so
coming
much.
in.
It's a pleasure.
Next week, we're talking about grade 11 probability, which is so closely linked to statistics.
It is.
Yeah. And thank you, Dylan, for joining us and watching all the channels.
Sure.
And we'll see you again next week.
Thank you.
Bye.
Bye.
Created using Powtoon.